Okay, here we go. iChem Lesson 3, Anatomy of the Periodic Table. Please make sure you have your viewing guide in front of you, or at the very least a periodic table, because we're going to work towards creating a periodic table that will allow you to visualize all of the patterns in the groups and the properties that we'll continue to talk about. So first, a quick history lesson. We've gone through some of this before. We know that Dmitri Mendeleev is the father of the periodic table. Multiple stories have been told about him and his cards, index cards with the properties, and he arranged them in order of increasing atomic mass. If you just take a minute and look at your periodic table, you may be able to pull out a few places where that is not true. In general, it's very true, but a few places there are some exceptions to that rule. One of his students came along, Henry Moseley, and sort of noticed this, and by that time the proton, the neutron, the electron, a lot of those things were discovered, and he was able to say a little bit more about the structure of the atom and use that to arrange the elements in order of increasing atomic number to create the periodic table that we know today. So periodic law is how the periodic table is arranged according to. So the periodic law states that certain elements and physical properties repeat themselves every 8 elements when the elements are arranged in order of increasing atomic number. So every 8 elements from left to right across the groups, the physical properties repeat themselves every 8 elements. And as you're moving along, that atomic number is increasing. Okay, so let's look. The columns, we're going to call them groups. So as you move from group 1 to group 2 to group 3, all the way to 8, they'll start to repeat when you come back down to the next period row in group 1 again. Okay, so there's major classifications within the periodic table. It falls into 3 groups. Metals, which are on the left of the periodic table. Non-metals, which are on the right, to the right of that zigzag line, and metalloids, which are found sort of along that zigzag line on either side of the line, immediately on either side. So what I need you to do is at the very least draw that zigzag line and know that to the left are metals and to the right are non-metals. If you would like to color code your periodic table, you are entirely welcome to if you feel like that's going to help you. But at the very least, I need to see the zigzag line so you can look at it immediately. To the left of this is metals, to the right of this is non-metals. What does it mean to be a metal, a non-metal, or a metalloid? So metals. They're typically solid at room temperature. Almost everything in that area of the periodic table is a solid here on Earth at room temperature. A lot of them conduct electricity and heat. Electrons move around more easily in these. They tend to be shiny, malleable, which means bendable. You can kind of change their shape. Ductile, and they lose electrons to be stable. So almost all of your metals will have a positive charge. Well, all of your metals will have a positive charge because they lose electrons to become stable. Non-metals. They're diverse in room temperature state of matter. Some of them are solid, some are liquid, some are gas. They're non-conductors. They don't conduct electricity. They tend to be insulators of heat. If they're solid, they're brittle. They're non-lustrous. They tend to not be shiny. and they tend to gain electrons to become stable. So our nonmetals to the right of that zigzag line tend to have a negative charge in their ions. The metalloids in the middle you can find them in the middle of these. Okay. So within the periodic table, we know metals, nonmetals. We're going to label a couple of sections. So on the far left, you can draw a box from lithium all the way down. Those are the alkali metals, ALKALI. Do not include hydrogen in these. You can see hydrogen is a non-metal, even though you find it at the top of that column in the periodic table. The next column over is alkaline, with an INE at the end, earth metals. If we're going to kind of ignore the stuff in the middle for a minute and come all the way over to the right and look at this last column, second to last column, we call the halogens, from fluorine all the way down. The last column we all know we call the noble gases. They're called noble because of the idea of being sort of snooty. They don't want to interact with anybody else. They are full electron configurations, full orbitals. They're happy and they don't need to react with anybody else. So those are your four main columns that you need to know. In the middle here, you have the transition metals. That's sort of everything. All the metals that are not in those first two columns are considered your transition metals. And then you have your inner transition metals. They're essentially still just transition metals, except you know that they belong right here in the periodic table. For the most part, we're ignoring these for the purposes of this class, but for completion, those are your main 6 sections of the periodic table. While we're here on this slide, before we move on, I just want to look at the numbers at the top of the column. The second number just goes 1, 2, 3, 4, 5, 6, all the way over to 18 on the right. That's just the numbering the columns. In class today and in the past, we've talked about groups. So all the A's are the groups that we talk about. Group 1, Group 2, then come over Group 3, Group 4, Group 5, Group 6, Group 7, and Group 8. We looked at patterns within those groups today, and now I just want to summarize those patterns, starting with the number of the valence electrons. So at this point, your periodic table should look pretty much like mine with all of these different sections labeled. If you're not quite done with that, hit pause before we move on to the valence electrons. If you're ready to go, let's start labeling the number of valence electrons in each of our main 8 groups. So the number of valence electrons. We saw hydrogen and everything down has 1 valence electron. This should look familiar. The second group, they all have 2 valence electrons. We skip over here, group 3, 3 valence electrons, and if you keep going through, you see the number of valence electrons grows with the group number and goes all the way up to 8 as you go along the periodic table. So if we look under lithium, sodium, potassium, everything down here, they all have 1. It's one of the repeating periodic patterns we're talking about. Everything in this column has 1 valence electron. Everything in this column has 2 valence electrons. And same thing, 3, 4, 5, 6, 7, 8. As we saw in our creating the periodic table today, that this valence electrons feeds into the idea of charge of the ion, the common charge of the ion. So the alkali metals, they have 1 valence electron. The goal is to have 8. Okay, so the noble gases over here, they already have 8. Nothing happens to them. They don't form ions. The rest of them gain or lose electrons so that they can form ions. The easiest way for this first column to be complete, to have 8, would be to lose an electron, giving it a +1 charge. The alkali earth metals, they have 2 valence electrons. The easiest way for it to get to 8 would be to lose 2 electrons, give it a positive charge. Same thing here. There's 3 valence electrons. The easiest way for it to get to 8, to the configuration of a noble gas, would be, come back to the middle in a second, would be to lose 3 electrons and get a positive 3 charge. Now this column here is interesting because it could either lose 4 to have 8 or gain 4 to have 8. Both of them are possible. So this column could have a plus or minus 4 charge depending on other circumstances. One or the other is more or less likely, and we'll talk more about that later this week. The next column, there are 5 valence electrons. 5 more electrons would give it 8. 5 more electrons would give it a negative 3 charge. Next column, 6 valence electrons. 2 more electrons would give it 8. 2 more electrons would give it a negative 2 charge. Last one, halogens. They have 7 valence electrons. They need 1 electron to become 8. 1 extra electron would give them a negative 1 charge. So in all of these groups, 8 groups, you can look at it and say what the charge of the ion would be. Noble gases, no charge, no ions. Now let's go to the middle. We neglected them, we skipped over them for a minute. Some of you saw this today in the creation of the periodic table thing we were doing. Some of you didn't get to see it, that's okay. We'll look at it tomorrow. What you need to know is that everything in here, transition metals, they're a positive charge. And we know that from looking at metals before. We know that metals all have positive charge. But the charges vary. And some of them, like iron, they can be +2 or +3. And lots of other examples within there that we'll look at further. But just know that the transition metals are positive, and there are lots of different options for the charge of the ion. Okay, so your periodic table should look a little bit something like this. When you come to class tomorrow, be prepared to start talking about the properties of our metals, nonmetals, and locating particular elements on the periodic table based on the patterns and the properties we see here right now. See you tomorrow.